Hey guys, how you going? This video takes a quick look at databases and some fundamental stuff that you need to know whenever you're studying anything to do with databases. So firstly, a few basics and some terms as well. You notice that as we go through this, there'll be a number of terms in bold, and there'll be words that you need to know. So the first thing to know about a database is basically the definition of a database is that it's simply an organised collection of data. By organised, it just means it's arranged in a certain way. The classic way to arrange data in a database is to use a table. We all know what a table looks like. It's stuff arranged with columns running down and rows running across. And typically in a good table, a well-organised table, each of the columns would have a heading to specify what type of data is in that column. A database is really no different. Great example of a database is actually the phone book. The good old-fashioned phone book, probably something that many of you don't even use anymore. But the old-fashioned phone book is a classic database. It highlights the point that a database does not have to be computerized. Most of them are these days in the modern world. That's the way we do things. But it doesn't have to be. If it's an organized collection of data, like the phone book, where you've got people's names organized alphabetically, listed with their address and their phone number, then that is a database. Each individual entry into that phone book showing a person's name, their address and their phone number is what we call a record. So that is one record, one complete set of data for a particular individual. Each piece of data, I suppose, or each category of data, in the case of the phone book, the categories would be name, address and phone number. Those things that are arranged in the columns are what we call fields. Okay, and each of those fields gets a heading that describes the type of data that's stored in that field. And the record that I referred to before, they are in the rows of the table. So columns we call fields, rows we call records, but that's the way that all data tends to be stored. To get into a little bit more detail then, database tables, once we get our data in a proper database, a properly organised database, there's some pretty important stuff that you need to know. You can see here that we've got some of those terms from before. We've got a record identified here, all of the data in a one row relating to a particular individual. In this case, all of that data relates to this individual, Philip Barker. Each one of these individual items is what's called a cell. So each individual cell contains one data item. And collectively, in a row, we have a record. These columns are our fields, and each of our fields has a relevant name that describes what sort of data is stored in that particular column. And that whole thing is a table. And that's how we store data in databases. The thing you need to really understand is that one of the key things we need to be able to do when we're organising data for a database is to search and identify every record. So the way that we typically do that is to use one field in our table to uniquely identify every record in the table. And we call that field the primary key. So that is the primary key of the table. It is the field that uniquely identifies each of the records in the table. In this case, student ID is our primary key. It is the field that contains data where that's the only data that's going to be unique. For instance, the forename field, that's got two Philips, so that's not unique. We can possibly have people with the same surnames in our database, and very definitely people with the same dates of birth. So the only field that is going to be unique in this database is the student ID. And in fact, ID numbers make excellent primary keys in databases, and we use those a lot for that purpose. If a field is left blank, if a cell is left blank in a table, we say that that's we call that null, a null field. Right? So null fields are ones that are allowed to not have data in them for a particular record. For instance, we may not know this person's date of birth, and in that case, we might not record it, and we can add that later. So an empty cell in a table in a database is called null. Sometimes we don't allow data to be null, and we want to have data everywhere, but sometimes you can allow that, and that's called a null field. So based on what we just looked at, have a look at this table and see if you can think in the next couple of seconds what might be wrong with that table. What's the problem that you can immediately see with that table? And we've got 5 fields there, shop, time, date, rating and comments. But the obvious problem with that is that there is no one field there that uniquely identifies all of those records. There's no primary key. So we have to have a primary key in a properly organised database table. So fairly easily, in this instance, we can just create one. We can just add an extra column, an extra field onto our database, and call it review ID, and assign a unique number to each of those records in that database that will then act as the primary key, the unique identifier for each of those records. So that's a really important concept with databases that we need to understand. Some issues, some reasons why we might need to think more closely and carefully about the way we organise our data is identified here. In this particular database, it's taken from a vet surgery, there is one table of data, and we've got a bunch of different fields all related to information from that vet surgery. And this is all stored in one table. That's called a flat file database. When you've got a database consisting all of one table and everything's together in that one table, that's called a flat file database. There are some problems with flat file databases, and it's why there's a better way to arrange it, which we'll explore in a second. But some of those things are listed here. So there can be some problems here. If you look at the data, you'll see that they exist. If Mary Carruthers, which is our top person in our database up here, if she happened to bring a second pet to the vet surgery, how would we record that? Well, the way this database is set up, we'd have to add another record with Mary Carruthers added again, and her address and her suburb and her phone number, and attach to that the details of the second pet. Well, that's what we call redundancy. If we're needing to repeat and re-record the same data again, that's called redundant data, and that actually makes our database not very efficient. So it's something we should try and avoid. And speaking of efficiency, that's sort of the next problem. If Mary's second pet was added and we've got her data recorded twice, what if she moves house? You know, that happens all the time. In order to update that, we would have to go and update both of her records, which is inefficient. That takes time that we don't necessarily need to spend, which means it can also lead to the third problem, which is the update anomaly. If we've got redundant data, the same stuff recorded multiple times, and when we need to update it, if we only update it in one place instead of everywhere, that can create conflicts between the data we've got stored, and we call that an update anomaly. Now, the other problem might be with the way this data is arranged. Let's have a look at Barkley the dog. Barkley the dog belongs to, just have a quick look, Barkley the dog belongs to Alice Donovan. Let's say Barkley sadly dies, passes away. And obviously Barkley's not going to come to our surgery anymore, so we go and delete Barkley's record. If we were to do that, delete that entire record, the details of Alice Donovan disappear with it, the owner. Alice might go and get a new dog or a completely different pet and still want to bring that dog to our surgery, but we've deleted her record. We've then got to go to all the effort of adding her details back in to attach it to the new pet. So that's called data loss. If we remove data that we otherwise would like to keep, we can cause data loss from our system by deleting records if our data is not well arranged. So there's a better way to arrange this data to overcome those 4 issues. We call that a relational format. So if we, instead of having a flat file database with all of that data in one table and separate it out into 3 tables like this, and we give each of our tables a name. We've got the owner table with details about the owner, and we give each owner a unique ID, so that acts as the primary key for the table, and all of the names and address details and phone number of the owners. They can then link to a table called visits, which tracks the number of all of the different visits and appointments that our different pets have. So that allows each owner to have a separate record whenever they bring a different pet into the surgery. And then also that then links to our pets. So each of our pets have their own table as well with their own primary key, their own pet ID, to uniquely identify that particular pet. And that allows pets to also have the same name, which is very, very possible, and same types and ages and things. And we can keep track of our data much more easily, and we can overcome those 4 problems from the previous slide of redundancy, inefficiency, update anomalies, and data loss if we use that method of arranging our data, and that's the typical way that we do that.